Let's talk about forces, mass, and motion. Have you ever wondered why a soccer ball keeps rolling or why it eventually stops? It's all about forces and motion. So let's break it down. How do forces affect motion? An object's motion depends on two main things. First, the sum of all the forces acting on it, and second, the object's mass. The forces acting on an object can either be balanced or unbalanced. Let's start with balanced forces. When the forces on an object are equal and opposite, they cancel out. No change in motion occurs, like this group playing tug of war. They will stay where they are and not go in either direction because the forces are balanced. Here's another example of balanced forces. A book sitting on a table. Gravity pulls it down, the table pushes it up, balanced. The book stays where it is. But with unbalanced forces, things change. If the forces are not equal and don't cancel out, the object will speed up, slow down, or change direction, like this group over here playing tug of war. Since the forces are unbalanced, this pull is stronger than this pull, the whole group will change directions and start moving this way to the right. Here's another example of an unbalanced force. Push a shopping cart, it moves. That's an unbalanced force in action. Now let's bring in Newton's laws of motion. Newton's first law states, objects at rest stay at rest. Objects in motion stay in motion unless acted upon by an unbalanced force. So, if you kick a ball, it should roll forever, but in reality, the unbalanced forces of friction and gravity eventually slow it down. Here's Newton's second law. Force equals mass times acceleration, or F equals ma. Here's what that means. More force equals more acceleration if mass stays the same, and more mass equals less acceleration if the force stays the same. So, a heavy truck needs way more force to move than a bike. When we talk about motion, we need a reference frame, basically a point of view to observe motion. Choosing a fixed point makes it easier to measure how fast or how far something moves. Think of watching a car. If you're standing on the sidewalk, the car looks fast. But if you're in another car going the same speed, it barely looks like it's moving. Choosing a good reference point helps us measure motion clearly. Now let's talk about planning investigations. Scientists love investigations, and motion is something you can test. Here's how to plan an investigation for motion. First, identify the forces like pushes, pulls, friction, and gravity. Measure the forces using tools like spring scales to find the size, also known as magnitude, of a force, and to also measure the direction. Change only one thing at a time, like the mass of the object or how hard you push it, but keep all other variables constant. Keep them the same. Don't change them. As an example, you could add weights to a toy car and see how that affects its speed when pushed with the same force, or run a completely separate experiment where you push harder and harder each time and measure how the speed is affected, but making sure to keep the mass the same. So remember, with balanced forces, there's no change in motion. With unbalanced forces, the motion changes. It's Newton's laws that help us explain how and why these changes happen, and you can personally investigate motion yourself using tools and data. Science isn't just something you read about. You can test it, measure it, and see it in action. Thank you so much for watching this video.